Here we're going to solve an applied problem that involves the area of a sector. Logan has a garden in the shape of a sector of a circle. The outer rim of the garden is 25 feet long, and the central angle of the sector is 50 degrees. She wants to add a 3-foot wide walk to the outer rim. How many square feet of paving blocks will she need to build the walk? If we look at this diagram that we've already drawn, see that we actually have two sectors to deal with. We've got a smaller sector here, that's the garden area, and we've got a larger sector that includes the garden area and the walk. They both share the same central angle of 50 degrees. It means the area of the walk, given by the equation, A equals 1/2 capital R squared theta minus 1/2 little r squared theta. Here capital R is the radius of the larger sector, little r is the radius of the smaller sector. We can clean this up by factoring out a theta over 2, because we have a half theta in both of these terms. So we get theta over 2 times big R squared minus little r squared. We see that the larger radius, the radius of the large sector, will be 3 feet longer than the small radius. That is, capital R is equal to little r plus 3. We can substitute that into our equation. We'll get theta over 2 times little r plus 3 squared minus r squared. This will be theta over 2 times r squared plus 6r plus 9 minus r squared. And that cleans up to theta over 2 times 6r plus 9. And we can actually pull out a factor of 3. So we'll get 3 theta over 2 times 2r plus 3. Now we need to know what theta and r, know the values for theta and r. Theta is given in the problem as 50 degrees, but to use it in this formula, we need to have that in radians. We can convert 50 degrees to radians by multiplying by pi divided by 180. That will give us 5 pi divided by 18 radians for our angle. We also need to find out what the value of r is. That's the smaller radius. We're told that the outer rim of the garden area is an arc length of 25 feet. We can relate the arc length to the radius, the equation r is equal to s, that's the arc length, over theta. Since we know what theta is now, we plug in our values, 25 and our value for theta, and we'll find that r is equal to 90 divided by pi feet. So that's our small radius. Therefore, we can plug in our value for theta and our value for little r into our equation. We'll get that a is equal to 3 times 5 pi over 18 divided by 2 times 2 times 90 over pi plus 3. And if we work that out, we'll see that the area is approximately 78.93 square feet. So Logan will need about 79 square feet of blocks to make the walk.